Testing for a real-time systems. First, you have to understand what are real-time systems. Real-time systems are all those systems where the time is critical. Something has to happen in the prescribed time limit. The time constraint is rigid. If something has to happen in 1 millisecond, it has to happen in 1 millisecond. Okay? For example, in flight system, in those systems where the life is involved, okay, for train system like say defense armaments. So here you see, if you microwave you're using 30 seconds you input, and after 30 seconds what happens? Microwave stops itself. And in this 30 seconds, you have pressed some button, but sometimes you can press another button, you can open the lid or open the door. These are interrupts. So most important thing in real-time system are interrupt. Interrupt are those which want attention. So it can be preemptive, it can be non-preemptive. Sometimes the interrupts are so important, like trap, they have to be accepted. Sometimes the real-time systems may say postpone attending the interrupt. For example, CPU. There are certain times the CPU will work and will wait for acknowledging the interrupt. Otherwise, some interrupt it has to acknowledge by stopping its work. So there are real-time systems, soft, hard real-time systems. So there are two partitions, hard and soft. Soft real-time systems like all the operating system which are RTOS, that is, they want certain time limit, this has to happen, but if it doesn't happen, there is not much of a concern. Hard real-time system, it is much of a concern, it can be catastrophic. So the time-dependent asynchronous nature of real-time application adds a new element to the testing, which is time. Asynchronous because anything can come at any time. Time is important. So the test case designer, he will use all the conventional test cases, but he has to understand and consider the event handling, as I am saying, like the interrupt processing, timing of the data, and the tasks are going, say, parallel. So parallelism of the tasks or the processes have to be dealt with. So test data for the real-time system in one state may result in proper processing. For example, test data at state 1. But the same test data for different state of this real-time system may lead to an error. This has to be checked and verified. Let me tell you that again, why it is difficult to test the real-time system. Time constraints are there, conventional methods cannot be used directly, and you can get some unpredictable outcomes. For instance, just take the example of this photocopier machine. Now this has a hardware and a software combined, so we can call it as a real-time system. So there are certain control keys. The real-time software that controls a new photocopier, it can accept operator inputs. That is, a user or a machine operator can hit a reset or darken with no error when the machine is making copies, everything is going good. But the same operator interrupts, same pressing of the button when the machine is not copying state, but it is somewhat jammed. The paper is inside, it is jammed. Now it can give you some other result, or it can give you some diagnostic code. Where is the jam? What is the location of the jam, cause of the jam? That is the error. Okay. So copying state, things can go fine. But what about the jam state? So there can be some code like error 003. I'm taking just an example. So software test must consider the impact of these hardware faults on the software processing, because now real-time system is a combination of a hardware and a software. So it's a combined combination. So if some hardware failure is there, you have to consider that also. So there are certain strategies. We are going to discuss a 4-step strategy for real-time software testing. First is the task testing. There are different tasks. Test for each task has to be done independently. You can always do the conventional task testing because you will see the logic, errors in the logic and the function. But the timing and behavior cannot be found here. You cannot uncover errors in timing and behavior. For that, you have to go for behavioral testing. And you can use certain, models which can be created by automated tools, or even you want to create it, you can create it. You can simulate the behavior of the real-time system. And then you can determine or examine its behavior as a consequence of some stimulus or external events. First thing in behavioral testing is you can use these state diagrams, or you can, automated tools are there, you can create your own model. So like the equivalence partitioning, these events which can be interrupts, it can be some control signals, you can also categorize them for testing into equivalence classes. And then you can use one of them and test it. So how to do this in behavioral testing? For instance, in a photocopier only, the events for the photocopier, the user might have the interrupts like the reset counter. Or there can be some mechanical interrupts from inside coming, like the paper is being jammed. Or some system interrupt, oh, the toner is low, the ink is low, this can come. And some roller is overheated, so this is some failure modes. So all these events, each of these events, these needs to be tested individually. And that can be done using the behavioral testing. Okay. What is the third one? Inter-task testing. See, once there is an error in individual tasks and system behavior, these are errors you have isolated, you have found and say done something for them. Now our testing will shift to the time related errors because this is a real time system. So there can be tasks which can communicate at any time. These are asynchronous tasks. When they are communicating or talking to one another, you have to test them with different parameters. For example, the data rates, the processing load. For this inter-task, whether there is some synchronization errors in these tasks. Let me tell you, we have already done for the 2-step individual task, we have checked, system behavior we have checked. I am talking about the inter-task testing, that is, different data rates you can change, the processing load, and there can be other parameters also, and that can give you this synchronization error. Now let me give you an idea. If the communication is happening using a message queue or a data store is there, that is from task 2, first thing goes to message queue, then goes to the task 1, or a data store is in between, then you can change the size of this data store, message queue, you can change or shorten or make the size more. Then you see what errors are coming. The fourth is the system testing. The software and hardware are integrated and then the system tests are conducted because we need to know the interfacing errors. What are the interface errors? Since the real-time systems, they are processing the interrupts. So testing the handling of these Boolean events, 0, 1, yes, no, you have to do it or not, is quite essential. Because in the system testing is an integral part. So as I am saying, the state diagram, using these which have already been made in the requirement modeling, tester would develop all the possible interrupts and what is the processing. So tests are designed to assess. There are certain system characteristics when you are doing system characteristics, like are the interrupt priorities properly assigned and are these interrupt properly handled with proper priorities? Is processing of each interrupt handled correctly? And then, because these two are important, then we have to see the performance also. Does the performance of processing time of each interrupt handling procedure conform to the requirements? Is it happening in time or it is exceeding it? Does a high volume of interrupts, because multiple interrupts can come, does a high volume of interrupts arriving at very critical times, that may create a system to dysfunction or the performance issue is there?